Okay, finally figured out how I need to just go to a different spot to stop recording so these videos won't drag on with me at the end. So we're into set 5-7, well, section in set 5-7, division of polynomials. It's not too bad. The long division method is the goofiest one, but I don't think you'll find it too difficult. I just did 2 examples of the regular ones. When you get one of these, in your mind, what you're doing is you're splitting them all apart. You technically have like 3 fractions. You just have the same LCD. So you can think in terms of 10x to the 5th over 5x squared minus 15x to the 4th over 5 plus 20, and then do all the work. Or once you're comfortable with these, once you understand them and you got some confidence, just look and say 5 goes into 10 twice, x squared, x fifth on top. The difference is 3, the bigger one's on top. So I have 2x cubed. Here, I know it's a negative because positive and negative. So it's a negative. 5 goes into 15 3 times. x4, x2, the difference is 2, the big one's on top. So negative 3x squared. Boom, got it. 5 goes into 24 times, going to be positive, so positive 4. 3 and 2, the difference is 1. The bigger one's here. Boom, done. All right, long division. You can pause this if you have to. Some students actually are not taught how to do long division anymore. I know my daughter's 7 and she's currently learning the wacky method of like even thousands, even hundreds, and then adding at the end. My 3-year-old is in and out of this room. I just want to get through this one last one. So here's an example of long division with polynomials. The key is worry about the first one. I have an x, I need to make it x squared. I need to make 2x squared. So I'll multiply that x by 2 to get 2x and multiply it by x to get an x squared. And what I'm doing is I'm subtracting as I go down. So I want this to be the same as this one. So it's going to be a positive 2x. And then whatever happens, happens when you work it out. So again, you can pause this if you have to make sense of my little notes. Okay, and then let me jump in and do a couple of these real quick. I already split this one up using this method. So number 3, I'm going to think in my head, negative 5 goes into positive 10, negative 2 times, x to the 4th, x squared, difference is 2, the big one's on top. Negative 5 goes into positive 15, negative 3 times, x cubed, x difference is 1, on the top. And then negative goes into a negative, it's going to be positive. 5 goes into 24 times. X squared, they're gone. X squared divided by x squared is 1. If we did it over here, we just do it individually, piece by piece. Now, what we do is we go a different step. This is the simplistic version of just basically dividing similar terms into one another. Well, now we can go one step further and get to where we were, kind of like what we were doing in the last section. We factor out and then look for similarities. So I can do an x minus 3 times x plus 2. That would give me my negative 6. It would give me a difference of negative 1x and my x squared. Well, then I have an x plus 2 and an x plus 2. I'm left with x minus 3 on the top. I'm done. That's technically division. That's this one divided by this one. But all it is factoring out and canceling. So anytime you can factor out and cancel, which is basically what we did here, we'd factor out a 5 and factor out an x squared and then cancel them with the bottom. Now, the difference comes with the long division method. Don't get too worked up with the long division method. First, the key is make this term equal this term. I need x to become x squared. I do that by multiplying by x. When I multiply by x, I get my x squared. I am going to do the opposite down here because I'm subtracting. So this is positive 2x. I'm multiplying everything here by whatever I put here. So I have x plus 2. Basically what I'm doing here is I'm taking x plus 2 and I'm multiplying by x. Just a minute, honey. I'm multiplying by x. And I do the opposite because I'm going to subtract. So I subtract 2x. When I do, I get negative 7x minus 7. So I look up here, and I need this to become hi honey. Okay. I need this to become a negative. Please turn it on. I need this to be a negative 7x. So I need it to be the same. Whoops. So I multiply by a negative 7. And now what I'm doing is I'm taking my x plus 2 and I'm multiplying it by a negative 7, then subtracting. So when I do this, I get negative 7 times x is negative 7x, and then I subtract it. So I do the opposite. Negative 7x. I need it to be the same as what I'm trying to eliminate because it will become the opposite. So negative 7 times x is negative 7x. When I subtract it, it's positive 7x. And then I get a negative 14. So I'm adding 14. My x's are gone. I'm left with a difference of 7. This is my remainder. So what happens is my answer is I have x minus 7, then I have a positive 7 over what I started with, x plus 2. Once I get rid of my variables, then I'm done. I can't do anything else when my variables are gone. Sometimes they work out. 1, 2, 3. Okay. Apparently they worked out on 2 of them from the homework. Oh no, I didn't even have us go that far. So never mind. The remainder, when we're doing the long division. Oh, I really don't think I even required that. We'll see. When we're doing the long division, sometimes they work out evenly. If not, we have a remainder. When we have a remainder, we say, well, there's 7 out of what we started with, x plus 2. And that's how I would write my answer when there's any sort of remainder. Okay? Hopefully you didn't think that was too bad. I mean, it looks crazy, but it's actually a pretty quick section. It's quicker than some of the others. And then we're done with chapter 5 with this, and we'll move on to chapter 6.